to give the floor to Thiemo BUCHNER. He's an engineer, an R&D engineer for Bosch Deep Field Robotics, and he's going to make his presentation in English.
Thanks for having me here to the NIO team. My name is Thiemo BUCHNER. I work for AGCO Fendt, and I'm the project lead of Mars. Maybe you know AGCO. It's the third largest manufacturer of agricultural equipment, and Fendt is one of the brands here. So Mars is a simplicity approach to agricultural robotics. First, I want to start with this question. Why do we want to change a running system? So back in the days of 1893, this was quite an advanced machine. It is an electrified threshing machine, and you see those people standing here are quite proud of this machine. And a clever guy back in those days said, the development of agricultural machinery can be considered as almost completed. And this was not just anyone, it was the director of the Agricultural Academy of Hohenheim. So maybe if you think today that we are already at the end of the development, maybe it's not true. So second, the Malthusian Trap. We heard a lot about population growth, and here we see in red the food required by the human beings living on this planet, and the gray lines show the produced food. So you see here, we already made once an improvement, once we escaped already this Malthusian trap, where the produced food is equal to the food required. So this we escaped by stepping from the horse on the tractor. So as the food required, this curve is growing superlinear, and the food produced is growing linear. At some point we will hit this curve, and for us engineers it's our duty to prevent this. So what technology is next? Maybe robots. And third, there is a huge potential maybe if you look at this picture. Mars is about seeding corn, and a corn weighs about 0.5 grams. And what are we using today for putting this into the ground is 15 million grams. Of course, we are laughing now when we see these pictures, but of course there are several reasons why we are doing this. But we really have to take a step back and rethink if we can do this in a better way. So let me talk about Mars as a different approach to agricultural robotics. Instead of designing this high-performance machinery and let the plants deal with it, we should more focus on the plant itself and go towards an agronomy-driven process. So look at the plant and its needs in terms of light, in terms of where do I place it, and what nutrients does it need. So this change of perspective is maybe a good thing when we deal with robotics. And different approach is also simplicity. So we want to have streamlined chassis, 4 identical wheels, rigid suspension, skid steering, as simple as it can get. Reduced hardware, so use a standard ECU, use standard communication hardware, no cameras, radar, laser scanners, and so on, which make the system complex and also very expensive. Robust software means, as we are using less sensors, we need less code, which means less errors, and less downtime, which is very important in agriculture. And please put the intelligence on the server side. So embedded safety means harmless weight and power, so a standard fail-safe. So now we see the one step back. Yeah, thanks. The concept of Mars. Can we just? Yeah, hope it stays like this. So we can also just start with the movie. Do we have sound?
Autonomously, 24 hours a day, while you can monitor the progress conveniently from your home, office, or wherever you are. A device that precisely took care of every single plant to leverage sustainability while saving energy, time, and money. Introducing Mars, the mobile agricultural robot swarms. How does it work? Select a field on the Mars app. Adjust parameters like seed type, seeding pattern, and seed population, and select the number of robots you are planning to use. After defining the position of the logistic unit, Mars automatically plans the whole process and calculates the needed time. Locate the Mars logistic unit next to the field and press Engage. The robot team will now accomplish the planting autonomously. Due to the small size and light weight, Mars robots are inherently safe, and soil compaction is negligible. The cloud. What if there was a device that was able to do the planting for you? Autonomously, 24 hours a day, while you can monitor the progress conveniently from your home, office, or where. The field and press Engage. The robot team will now accomplish the planting autonomously. Due to the small size and light weight, Mars robots are inherently safe, and soil compaction is negligible. The cloud-based system maintains a geo-referenced record for each seed. Each of the robots is connected to the Mars cloud where all data is processed, while the Mars app allows progress monitoring from any mobile device. The supervising control system makes sure every robot returns to the logistic unit in time for recharging and seed refill. In case of a malfunction, Mars automatically recalculates the mission on hand, and other robots of the team will step up to get the job done. Imagine the possibilities of Mars. Use just a few robots for small fields, or employ a big fleet for large-scale agriculture. All the data Mars provides is easily available for further analysis and improvement of the crop production process. Knowing the exact location and seeding time of each plant enables a geo-referenced record from seeding through crop care to harvest. Supporting a plant-specific and exact supply of water, nutrients, and plant protection takes precision farming to a totally new level. Productivity and sustainability for the farm of the future. This is Agriculture 4.0.
Okay, now we solved all technical problems. So here you see a picture of two prototypes we have at the moment working on the field. So we are just starting with field testing. So maybe next year we can present already some results. So after this, I want to talk shortly about the impact Mars can have. So first of all, comfort. Autonomous operation is, I think, quite clear. Telemetric maintenance and remote updates, so we can do bug fixing on the fly and do system updates on the fly, and we can run diagnosis from any location in the world. Cost reduction. So we have no cab and no operator environment, so no air conditioning, no driver seat, no displays. We use minimum sensors. The main sensor we are using for Mars is a GNSS sensor to get the position, orientation, and speed, and the odometry from the wheels. And we need less materials as the robots are very small, 50 kilograms maximum weight. In terms of efficiency, we can expect more yield because we can react to the soil conditions and seed individually we need less seeds and chemicals because we store each seed location and can treat it later on individually. And of course, we need less operators because we only have to transport the CLU to the field, and then the robots take over and do the seeding autonomously. In terms of safety and reliability, the robots are very small and lightweight. As mentioned before, 50 kilograms max and maximum length of 70 centimeters. So less power and less heat, less power. We are having like 500 watts of wheel power. And in terms of reliability, we have independent units, which means that a single robot breakdown is not causing any problems. In terms of productivity, I can use 1 or 100 units. It depends on the job I have on hand. And of course, the time. I can work with the robots 24/7 hours, which is very important if you see the climate change. So we can have earlier field access. We can work very close to villages because we have low noise emission. And we can also do a very quick service because we don't need any special tools or special workshops. 2 people can easily lift this robot on a desk and you can repair it. And last but not least, sustainability. We have 80% less ground pressure, which means less soil damage. We use low energy, which reduces CO2 emission by 80% compared to a standard planter. We have low noise, no oil spillage, and we are ready for renewables. So we can just replace the battery with a fuel cell. Okay, so that's it, and thank you very much for your attention.
Thank you, Thiemo.